Alright, what we're going to do now is the same process that we used before, but in reverse. So in the previous video, we took a function and we found some key information from the function that we were able to use to graph it. What we're going to do now is we're going to take the graph and use the key information from the graph to work backwards and get the equation. So the first step in doing that is just identifying that key information. So what I've done here is I have identified the vertex that's here. Here's our vertex. And we really also have the axis of symmetry, which would just be the -1. We have the y-intercept, which is going to be really important. We have the x-intercepts, also very important. And then any other point that you might find. I got this example out of the book. If you want to follow along, it actually has the coordinate plane on there, so that you could see how I got these points. But this is just some key information that we can use to help find this equation. So the first thing we'll do is find C. Now if you recall from the previous video, C is the y-intercept. So finding C is a really easy part of this process. If you recall from the video that we did prior to this one, the C is just the y-intercept. So that's why I brought this back up. So our y-intercept is here. It's at 0, 8, so our y-intercept is 8. So C is just simply 8. So this equation is going to be ax squared plus bx plus 8 equals f of x. So what we already have now is we're starting to get part of this equation. We still don't know a or b. We're going to have to find that. But we do at least know C. And just like the process go in the other direction, C doesn't really require any arithmetic. Now the next thing that we're going to do, instead of using y-intercepts, is we're going to use the x-intercepts to find a function with the same solutions. Now I want to be really clear, it's going to have the same solutions, but it is not an equivalent function. The function that we're about to find is not the answer, but it is something that we need. It's a step in the process to finding the actual equivalent function, the one that is equivalent to our function that we have in the graph, not just one with the same solutions. Those aren't always the same thing. So our x-intercepts are -4 and 2. Just getting that information from right here, -4 and 2. So we have -4 and we have 2. Those are our x-intercepts. So what that means is x equals -4, x also equals 2. We're going to use these solutions to create binomials that could be solved to get those solutions so that we can then multiply those and get a function. We're basically going to do the whole factoring process, but in reverse. So if I had the equation x plus 4 equals 0, that would give me the solution -4. If I had the equation x minus 2 equals 0, that would give me the solution of 2. Well, where would those come from? Something like this. X minus 2. So we have two binomials. Now we're going to take these binomials, multiply them together. Again, we're just doing the opposite of factoring. So what we're doing now is distributing. You have x squared minus 2x plus 4x minus 8. So we have x squared, -2 plus 4 is +2, minus 8. So what we have now is an equation that has the same solutions to our function, but it's not the same function. And the reason that I know it's not the same function is the C is not the same. We know that C of this function we have in the graph has to be +8. This is -8. That's not right. So now we need to account for that, and we need to fix that. But using rules and properties that we know about equations, that will change the equation but won't change the solution, because we know this has the same solution as our function. So we don't want to change the solutions, but we do want to change some things about it so that it does end up having the same C, so that all the information is accurate. Now, one of the other things that we don't know, and this is just kind of going to take care of itself, but we still don't really know what a and b are supposed to be. If we change this 8 to a negative 8, it's certainly going to change some other things about the equation, but we still don't know what a and b is. So what we're going to do is we're just going to kind of establish a, and we're going to distribute that in. Ax squared plus 2x excuse me, plus 2ax minus 8a. Now, if this seems pointless, here's why we did that. We're going to now take the 8a. We know that that is supposed to be positive 8. We know that negative 8a is supposed to be positive 8. Well, what do we have to multiply negative 8 by to get positive 8? A is negative 1. So now we know what A is as well. And through finding A, it's also going to help us identify what B is supposed to be. So negative 1x squared plus, well, 2a, 2 times negative 1 is negative 2. So negative 2x, and then negative 8 times negative 1, negative 8 times a, is positive 8. So now we have a function with equivalent solution, so it has the same solution as our graph, and it also has the same c, and all of those things are going to work together. So this function is our graph. Now we could clean that up a little bit if we wanted to. We could say negative x squared minus 2x plus 8 equals f of x, and that is the function of the graph.